So if you recollect whatever we have discussed till now, what is that we did? We just understood the basics of this chapter. So first, what did we try to understand? We understood what is an electric charge, what is an electric field, right? Then we tried to answer the question of, okay, what is the definition of electric charge that is going to be in terms of an atom, right? With the help of an atom, we took the definition of electric charge. Then we saw the methods in which you can create charge on a material. Then we discussed about the basic properties. So these are the three important basics or fundamentals, rather, I would say, which is needed for us to build the remaining part of the chapter. Now we are going to get into the mathematical part of it. Right. Ultimately, what are we doing by creating charge? We are trying to make the different objects interact. So what do I mean by interact? Interact means, are they literally talking to each other? No, right? Then what is it? Attraction or repulsion. What is it basically? It is another way of saying push or a pull. So if you go back to your 9th standard basics, what is the push or pull? So the first thing that we need to understand is how each material is going to exert or interact with each other in terms of force. For that, we have a relation which was given by scientist named Coulomb, okay, which we call it as Coulomb's law. Right. So let's see. First, listen to the concept, then you can write it down. See, if suppose I have two charges in my hand, where I would rather stress on the point, I need to have two point charges in my hand. What do you mean by point charges? Point charges are, you can basically call them as particles, where the size of the particle can be ignored compared to the distance of separation between them. Right. So basically, a point charge is a particle charge also. So first point to be noted is Coulomb's law is applicable only for point charges. Right. So you'll be able to recollect when I tell this law, right? You'll be able to recollect some other law which you learned last year. I hope you would have guessed it by now. Right. If suppose I have 2 point charges of value, right? Q1 and Q2. And let's say the distance of separation between them is R. Right. Then there will be a force that is existing between these two charges, such that the force is going to be directly proportional to the magnitude of the charges. Correction. Force will be directly proportional to the product of the magnitude of charges. Right? And it is inversely proportional to the square of the distance of separation between them. Right? I hope you would have recollected something else. It is Newton's law of gravitation, right? So there you would have learned F is directly proportional to M1 into M2 and inversely proportional to R square. Instead of M1 and M2, what do we have here? Q1 and Q2. And another difference is gravitational force is always attractive. Electrostatic force can either be attractive or repulsive. Because we know that like charges repel and unlike charges attract. In this scenario, it would both be positive charges. Okay, it can be in any manner. That is why when I wrote this F is directly proportional to, I am stating it very clearly. It is, the statement says that it is directly proportional to the product of, what did I put? I put the modulus. Product of magnitude of either of the charges. You can ask me, sir, how will I take the plus and minus into consideration? That will be taken care by vectors. So vectors will take care of it. You need not worry about it. Okay. So the force is directly proportional to the product of magnitude of either of the charges. And it's inversely proportional to the square of the distance of separation between them. So when I combine both these values, I'll get F is directly proportional to magnitude of Q1 into magnitude of Q2 divided by R square. So obviously, for me to remove this proportional symbol, I need to introduce a constant. And that constant will be something like this. It is K times magnitude of Q1 into magnitude of Q2 the whole divided by R square. So K in this case is going to be 1 divided by 4 pi. It's called epsilon naught. So 1 divided by 4 pi epsilon naught into magnitude of Q1 into magnitude of Q2, the whole divided by R square. Okay, where this symbol is called as permittivity of free space. It's called permittivity of free space. What is the significance of it? I'll tell you. So, I hope you're able to understand. F is equal to K times Q1 into Q2 divided by R square. The K is replaced with 1 by 4 pi epsilon naught. And this epsilon naught is called as the permittivity of free space. If you don't put that circle at the bottom, it will be the permittivity of some other medium. So in physics, one of the notations way is for any constant, if you put a circle at the bottom, especially in your 12th standard, that is something related to your free space. Okay, in some other chapter, you will see something like this also. This is called as mu naught, which has something to do with magnetism. So in electrostatics, we use epsilon naught. In magnetism, we use mu naught. As of now, have this in your mind. Okay. So I hope I'm clear to this step, right? Now, this 1 by 4 pi epsilon naught has a value which is already calculated. We need not break our heads. So for that, it is 9 into 10 power 9. Now I want you guys to check the units and tell me. 1 by 4 pi epsilon naught value is 9 into 10 power 9. What do you think will be the units? Look at it. So it is something like this. F is equal to 1 by 4 pi epsilon naught into Q1 Q2 divided by R squared. So this 1 by 4 pi epsilon naught will be equal to how much? F into R square divided by Q1 into Q2. Am I right? So F is measured in Newton. R square is measured in meter square divided by Q1 into Q2. Charges are measured in Coulomb. So Q1 into Q2 is going to be Coulomb square. So 1 by 4 pi epsilon naught takes the value of 9 into 10 power 9 Newton meter square per Coulomb square. Where is this calculated? It is calculated from the speed of light. That value we need not worry about how it has come. Okay, this is 9 into 10 power 9 Newton meter square per Coulomb square. And if you calculate the value of epsilon naught alone independently using this expression, you will get it as 8.85 into 10 power minus 12. Can you tell me the units? Can you tell me the units? It will not be C. It will be reciprocal. So it will be Coulomb square per Newton meters. Are you able to understand? I hope this is simple, right? So just you substitute the value of pi as 3.14, 4 into 3.14, take it to the other side, right? Or sorry, you bring this value this side and take epsilon naught to the other side, you will get this value. Okay, so this is all about Coulomb's law, and whatever mathematical expression I've given you is given in the scalar form. Because I spoke only about magnitude, I never spoke about direction till now, right? So Coulomb's law in scalar form, right? First, I'll give you, write down the heading. I'll give you the statement, right? Then you can copy this mathematical part. So you wrote the heading, Coulomb's law, right? When 2 point charges, Q1 and Q2, when 2 point charges Q1 and Q2 are separated by distance R, then the electrostatic force of attraction or repulsion, is observed to be first. Is observed to be, then put a number. So first, directly proportional to the magnitude of the charges is directly proportional to the magnitude of the charges and second, inversely proportional to the square of the distance of separation between them and inversely proportional to the square of the distance of separation between them.